All right, guys. So earlier I did a poll and I asked you guys I forgot what was on the poll, but I remember one of them was airspace, and that's the one that got the most votes. So that's what I'm going to teach today. So we're going to go over airspace right now. Okay. So you guys are going to learn all about airspace. I hope you guys enjoy my presentation. And let's get started. All right. So in aviation, we have a couple of different airspaces, right? And each one of these airspaces have different requirements and different rules that we need to follow when we're flying through these airspaces, okay? So we have a couple of different ones. So we have class Alpha, Bravo, Charlie, Delta, Echo, and then we have Golf, and then there's a couple different Echo ones that we're not gonna get into today, but just for your knowledge, there's a couple different Echo ones to be aware of. There's like 7, and then we have what's called special use airspace. So don't worry about those for right now. I'm just bringing it up so that you know that they exist. But today we're just going to talk about controlled airspace, and we're going to get a little bit into uncontrolled airspace, which is class Golf. So controlled airspace is exactly that, airspace that is controlled. That means that air traffic control can see you on their radar. So we're going to start with class Alpha. So class Alpha, right, is pretty high up. And Cessna pilots or GA pilots, flying Cherokees, and trainers, we're not going to be too concerned with class Alpha because it's way up there. And that's not an altitude that we're going to be flying at, okay? So class Alpha starts at 18,000 feet, okay? And it goes up to 60,000 feet. And so what do we need to fly in through this airspace, right? So the first thing we're going to talk about is pilot requirements. Okay, what do we need as a pilot to fly through this airspace? What certifications do we need? Okay, so to fly through class Alpha, this is the only airspace that you kind of controlled airspace that you can't fly through without at least a private pilot certificate. Okay, so you need to have at least a private pilot's license. Not only that, but you also need an instrument rating. So to fly through class Alpha, you need to be at least a private pilot with an instrument rating, okay? So that's very important to know. What equipment do we need on our aircraft for class Alpha? So we need what's called a mode C transponder, okay? That's what gives ATC the ability, our aircraft, to transmit our altitude. So our mode C transponder, and we're going to need ADS-B out. And then what we're going to also need is two-way radio communication. Two-way radio. Why do we need that? Well, because we need to talk to air traffic control. Why do we need to talk to air traffic control in class Alpha? Well, because to fly through class Alpha, we need to be on an IFR flight plan. We have to be on an IFR flight plan. We can't be flying through class Alpha on VFR. I know this is a lot of information, but as you continue to watch my videos, you'll learn more and more about aviation, and you'll learn what an instrument flight plan is. We're not going to get into that today. So, what are our weather minimums? So, our weather minimums, we don't have weather minimums for class Alpha. And let me reposition something here. Okay, Alright, so our weather minimums. So all our controlled airspace, we need to have some type of weather minimum. For class alpha, we don't have weather minimums. Okay? And the reason for this is because we're on an instrument flight plan. Okay, so if you're on an instrument flight plan, that means you can fly through clouds and stuff like that. So that's why you don't need to be, there's no need for weather minimums in class alpha, because since you're on an instrument flight plan, you don't need to be avoiding clouds. You're just going to be vectored right through them, okay? And we also have speed restrictions. So what speed restrictions do we have? If we're in class alpha, we're not to exceed Mach 1, okay? So you're flying a really fast jet and it's capable of going Mach 1, you fly to class alpha, that's a no-go. You can't do that. You need to slow that thing down. Okay, so what else do we want to touch upon for class alpha? Let me check. The last point with class alpha, whenever pilots are flying through this, we all set our altimeters to our barometric pressure of 299 or 2. So this is so that all the pilots are reading the same altitude. So if air traffic control tells you to climb and maintain this altitude, you know that what altitude they're talking about, and they're going to be able to maintain separation between other IFR traffic in class alpha. So all pilots at this altitude in class alpha, flying through class alpha, set their pressure altitude to 299 or 2. So that's something to be aware of. Okay, so that's your class alpha. Your next airspace that we're going to be concerned with is our favorite airspace. No, I'm just kidding. But our next airspace is class Bravo, okay? And so this is more or less what class Bravo looks like. It's big. Big airplanes fly through class Bravo. It's busy. So think of that, B for big, B for busy, Boeing, big airplanes, okay? So this is your class Bravo. These are the biggest airspaces in the country. Miami International is a class Bravo. So MIA, LAX, JFK. Okay, these are all examples of class Bravo. Now, the thing about class Bravo is that they're shaped to the needs of that particular airport. Okay, so they're not really standardized like some of the other airspaces that we're going to get into here in a second. They're all kind of like built a little bit different, but typically they go up from the surface of the ground up to 10,000 feet. Okay, so that's your altitude, your altitudes, right? And on one side it might go up to like 6,000, right? You have one shot that's 6,000. Let me see. You might have one shot that's 6,000. The other one could be at like 5,500. Down here could be 2,000. And this one could be like at 3,000, right? There's really no set standard on how a class Bravo is supposed to look like. It's just tailored to the needs of that specific airport, okay? So that's kind of like how your class Bravo is shaped. And so what are we going to need as a pilot to get through this class, to this airspace, right? So in this airspace, hold on, let me turn on the fan because it's kind of hot in here. In this airspace, we need to be at least hold a student pilot certificate, and not only that, but you can't just fly through here as a student pilot, because this is a really busy airport or airspace, and they don't want student pilots just flying through this. So I need to give you an endorsement to be able to fly through class Bravo. Okay, so you can fly through here with my endorsement. Okay, so that's what we need. You need to be at least a student pilot with an endorsement from an instructor. What does our airplane need to have? Our airplane needs to have mode C transponder, and we'll get into the why in a second, ADSBL. And because there's a tower here, all Class Bravos have a tower. Every single Class Bravo in the country has a tower. We need to have two-way radio to talk to them, okay? How are you going to talk to the tower if you don't have a radio? So that's why we have radios. Radios is mandatory equipment for flying through Class Bravos. And what are our weather minimums for here, okay? Our weather minimums, you need to have, and I'm going to put this over here because I want to make it a little bit more clear. For weather, we need 3 statute miles of visibility, and you need to be clear clouds. Okay, so there can't be any clouds around us, and we need to have at least 3 statute miles of visibility. Our speed restrictions inside of the Bravo, if we're inside the shells of the Bravo, we're not to exceed 250 knots. Okay? Inside. Outside, underneath the shelf, is we're not to exceed 200 knots. Okay, so what do I mean by that, okay? So you see how this shelf right here starts at 5,500 feet? Let me see, maybe you're gonna not be able to see this. Let me sew this up for you. So this shelf starts at 5,500 feet. If you're flying through here at 4,000 feet, you can't exceed more than 200 knots, okay? So that's the rule with that. Not to exceed 200 knots. What else do we want to talk about here? Okay, so another important concept. There's 2 more important things that we want to talk about. First one we'll get into is what's called the Mode C veil. So the Mode C veil is a veil. It's like a big giant circle that surrounds the Class Bravo in a 30 nautical mile radius, right, of the primary airport. So to get a visualization like this, I'm just gonna erase it for you here in a sec, but I'm just gonna draw it out. So if this is the Mode C veil, right, it's a giant circle. This circle is huge. Okay, the circle is has a 30 nautical mile radius from the center. So from the center, the point in the center of the airport, it extends out 30 nautical miles. Okay, so if that's your Mode C veil, your Class Bravo would be something like this. Inside, you see what I'm talking about? This is your Class Bravo, so we're looking at it from outer space. Your Class Bravo is right here, and then you have your Mode C veil right here. Right here, we're looking at it from the side. This is from the side, this is from outer space. Okay, so that's imagine that's your Mode C veil. And I'll leave that up there for a second. But whenever we're operating within the Mode C veil, we need to have Mode C transponder with ADSBL. That's just the rule. We can't be operating these airspaces without that equipment, and that's why it's mandatory. So we can't be within a Mode C veil if we don't have Mode C transponder and ADSBL. Okay, so that's one important thing to know about Class Bravo. The second other thing that you might see with some Class Bravo is what's called VFR transition routes. Your VFR transition routes it could go either way. It's this way, that way, and basically what they're for is to help air traffic control move VFR traffic through their airspace. So you would have to request this with air traffic control, and if they approve you, you're just gonna follow it down using the sectional. It's depicted on the sectional, so you just follow it down, you fly through there. Okay, so that's your VFR transition route. Alright, so that's your Class Bravo airspace. This one was the biggest one. And I'm going to erase this. The next airspace we're going to get into is your Class Charlie. So it's another step down. It's still a big airport, pretty busy airport, but not as busy. So your Class Charlie is, imagine an upside down wedding cake, right? So this is your Class Charlie. I'm not a big fan of this marker. Class Charlie. And typically they come from the surface, like a Class Bravo is at the surface, up to 4,000 feet. But they're kind of an upside down wedding cake, right? I hope you can see that. Okay, so this is your Class Charlie. Let me make this a little bit nicer. Hold on. So you can make this a little bit easier to read. So it's from the surface, right? And then this from the surface up to 1,200. You have the second shelf. So the first shelf goes from the surface to up to 1,200, and then the second part goes from 1,200 to 4,000 feet. So that's typically how they're shaped. Now, some of them are shaped a little bit different depending on the needs of the airspace, but for the most part, this is how they're depicted. So this upper part has a radius of 10 nautical miles. Okay, 10 nautical miles. The bottom part has a radius of 5 nautical miles. Okay? Now, what do we need as a pilot to fly through this? As a pilot, all we need to do is be a student pilot. And something that I didn't touch upon for Class Bravo, so let me go back to Class Bravo. For Class Bravo, to be cleared into the Bravo, when you request it with air traffic control, they have to tell you when you want to fly through here that you're cleared through the Bravo. When you hear that you're cleared through the Bravo, you're allowed to fly through it. So that's how you're able to fly through a Class Bravo. For Class Charlie, all you have to know is that you have to hear your tail number. So if you request to land, say November 107 Romeo Alpha, we're 10 miles south, inbound full stop, Class Charlie, they say Roger, 7 Romeo Alpha, make straight in for the numbers, then you know that you're eligible to fly through here. You're cleared through them, because all they need to do here is acknowledge your tail number. All you need to do is be a student pilot, hold a student's pilot certificate, and your aircraft needs to be equipped with Mode C transponder, ADS-B, and two-way radio. Why do you think we need two-way radio? Well, every single Class Charlie in the country has an operating control tower. They'll have a tower. And how are you going to talk to the tower without having two-way radios? So that's why that's required to fly through here. Weather minimums. To fly through a Class Charlie, the weather minimums is 3 statute miles visibility. Okay? Then you have to maintain 500 feet below, 2,000 horizontal, and 1,000 feet above the clouds, okay? So these are the margins you have to operate. So if there's a cloud, you have to be operating 500 feet below it, 2,000 feet to the side of it, and 1,000 feet above it. So depending on where the cloud is in relation to you. Okay, so what are our speed restrictions? We're not to exceed 200 knots within it, or underneath it, 200 knots. Okay, so we can't go faster than that within here. Now on to the next airspace. The next airspace we're going to talk about, we're going to make 2 examples here. This is going to be our Class Delta. Okay, and I'm going to draw this here just to illustrate an example, but really the point where I want to get us to, we're going to talk about it over here. Okay, so Class Delta. So Class Delta looks something like this. And this is usually up to an altitude of 2,500 feet, and on the sectional chart is going to be indicated like that. You're going to see a 2.5 like that, okay? And this is your class delta. All right, so your class delta is this. What do we need to fly through that, right? And they also have, all class deltas have an operating control tower, and yeah, they all have an operating control tower, and they're at the surface. They start at the surface of the ground up to 2,500. So we need to be at least a student pilot certificate. 2, we just need 2-way radio. That's all we need. Okay? And because we need to talk to the tower. And our weather minimums for class delta is the same. So we need to be 1,000 feet above, 2,000 feet horizontal distance, 500 below, and we need 3 statute miles visibility. Okay? Those are our weather minimums for class delta. Speed restriction, we're not to exceed 200 knots. How do you get cleared into a class delta? So if we're flying in, we just need our tail number acknowledged, similar to the class Charlie. So we say November 107 Romeo Alpha, we're 10 miles southwest, inbound full stop, whatever. They're gonna come back and say November 107 Romeo Alpha, cleared, make straight in for 9 right. That's all they need to say, okay? So that's how you get cleared into a delta. Okay, so the last airspace we're gonna get into right now, we're not gonna get into uncontrolled airspace because I'm super tired. But the last one we're gonna get into today is Class Echo. And then tomorrow I'll give you guys a little bit more of a breakdown into Class Echo, and we'll get into Class Golf. But today we're just gonna get into Class Echo. Class Echo. Okay, Class Echo is a little bit tricky because it's found in a lot of places. It's found everywhere. So the first place you're gonna find Class Echo. So remember how we talked about Class Alpha being up to 60,000 feet, right? It goes from 18 to 16,000 feet, 60,000 feet. Above 60,000 feet is again Class Echo. Okay, so you break out of 60,000 feet, you're in Class Echo airspace again. Class Echo airspace it's also found below Class Alpha. Okay, so it's found below Class Alpha, and depending on your altitude, the weather minimums change. So let's start with above 10,000 feet. So above 10,000 feet, all we need to do is be a student pilot, and we don't need any equipment. Actually, hold on, I don't think that's accurate. Let me double check that. Above 10,000 feet, we actually need a transponder. And ADS-B out. Okay? 3 are weather minimums. It's different. We need 5 statute miles visibility. And then we need to maintain what statute mile horizontal distance from the cloud, 1,000 above clouds, 1,000 below. And so the idea is, because if you're flying up in higher altitudes, you're gonna be flying with aircraft that are faster, so you need more time to react, okay? So that's why you need more visibility. Okay, so that's for that. Below 10,000, same, you just need to be a student pilot, hold a student pilot certificate. 2, you don't need any equipment for this. 3, weather minimums go back to 3 statute mile visibility. 1,000 feet above, 2,000 horizontal, 500 below. Okay, so that's your class echo. Okay, it's pretty much. Sometimes it goes to the surface, and again, we'll go into more. Like in what scenarios you find class alpha echo tomorrow, and we'll get into class golf tomorrow because we didn't touch upon class golf. So I'm gonna leave the board exactly how it is, and then tomorrow we'll get into to class golf. So this is your airspace chart for today. Okay, hope you guys enjoyed my lecture.